Thanks for coming and welcome to NUG 2014. This is going to be a kickoff event for our year-long celebration of NERSC's 40th anniversary, so look for other events throughout the year. I'm Richard Gerber, for those who don't know me. I'm the Senior Science Advisor to the Director at NERSC and also the Group Lead of the User Services Group. So to get started, I'm honored to introduce Jonathan Carter, the Berkeley Lab Computing Sciences Area Deputy.
So if any of you are not familiar with Berkeley Lab, and looking around the audience, that seems pretty unlikely, but I'll talk to this slide. Anyway, we've been around for 80 years. So we have about just over 4,000 employees, and the budget last year was just over $800 million. We have a close affiliation, obviously, with the University of California at Berkeley and share a sizable number of staff. We have an incredible presence on the Hill of amazing scientists, Nobel Prizes, National Academy of Science members, and National Academy of Engineering and Institute of Medicine members. So we'll be talking mainly about NERSC, of course, this week, but we have a number of other really world-class facilities at the lab, from the ALS to the National Center for Electron Microscopy, to the Nano Hub called the Molecular Foundry, to NERSC, obviously, to ESNet. There are all these facilities together. We have probably over 7,000 visiting scientists, many of them from universities who come here to use these facilities and do great science. So some of the Berkeley Lab science focus areas, I've drawn this kind of Olympic ring themed to capture them all. Obviously, we have a big effort in biosciences, looking mainly at synthetic biology, an effort in energy and environmental sciences, looking at energy efficiency of buildings and similar things. With the ALS, we're working in photon sciences, understanding the structure of small molecules and looking at probing the reactions of them. Large effort in physics and cosmology, obviously high energy physics, and computing sciences, which I want to go into a little more detail later. But I think a critical thing to point out is that computing actually underpins many of these other efforts in a very fundamental way. And some of the talks we'll be hearing about later today and later in the week will really bring this out. The efforts of K-base and computing for the JGI in biosciences, to a new project that Jamie Sethian is PI of called Camera, which is looking at interacting with light sources to produce new mathematical algorithms to get them their answers much quicker than before. So these connections are everywhere, and we recognize our role as really fundamental in advancing all these other science areas. So in a little bit more detail, computing sciences at Berkeley Lab is broken into 3 divisions. The NERSC facility, I have a picture here of the latest accepted machine at Edison. The scientific networking division, which runs the ESNet facility, which is a national fiber footprint, providing high bandwidth and low latency connections between all the major DOE labs. And also we have a computational research division, which you might roughly break up into 3 pieces with talent in applied math, computational science, and computer science. So a little bit of NERSC history, as it is the 40th anniversary thereof. And I hope I have all this correct, because I only know the history personally from '96 onwards. But apparently the center was founded under the name the Controlled Fusion Research Computing Center back in 1974. And then a couple of years later, it went on the network as the National Magnetic Fusion Energy Research Center. It started with pretty humble beginnings. There was a CDC 6600, which I believed was left over from, or orphaned from one of the weapons programs, and that was co-opted into service. And then later on, a CDC 6600 was purchased. Now, when Cray became a separate company, NERSC, as it became then, started putting into production various of the Cray vector machines for the years up to about 85, I guess. About 1994, the first forays into massively parallel processing began. And we may not, from our vantage point now of 100,000 cores, we may not recognize it really as massively parallel processing, but it was at the time maybe 128 processors. That was the T3D. Then in 96, NURSC moved to Berkeley Lab, and we began to diversify in some ways, picking up a custom system for dealing with particle data processing. And we took massively parallel computing mainstream. The T3 was our flagship machine in 96, 97. We began to migrate all the users from the vector machines onto these massively parallel systems. Then we shifted away from Cray in 2001 when we purchased an IBM SP3, and that was it was upgraded in 2 events, and we hung on to that until 2007 when we put into production a Cray XT4 Franklin that was upgraded to an XT5, and then this is much more recent history as we put into service the Hopper system and the Edison system. So after more than 10 years away down in Oakland, NURSC will be moving back to the Hill to be closer to the other divisions. It'll be moving into the building that you most probably saw being constructed just down the hill from us here, the Computational Research and Theory building. It's going to be a 4-story building, 2 floors of offices, 1 floor of machine room, and the lower level is the mechanical. This will be a very energy efficient building. We'll be able to take advantage of the almost year-round cool air, which we can use to bring in and cool the systems without any extra mechanical chilling capacity. So this project, it's going very well. It's on schedule, and we're hoping to move some of the systems in maybe fall of this year or maybe very early next year for the office occupancy. So that's all I really wanted to say, but I wanted to pause for a moment and remember one of our friends and colleagues, Mike Welcome, who passed away suddenly this weekend. Mike spent his career at the National Lab System, first at Livermore, and then he moved with NURSC to Berkeley in 96. His career spanned a great many different research areas, from applied math to machine job scheduling on the T3, to working with parallel languages, to working with the Future Technologies group in CRD. Most recently, Mike was working with the Storage Systems group at NURSC. Those of us who worked with Mike will remember that he always had a cheerful disposition. He jumped into projects that other people would have balked at, and he kept really NURSC on track in many ways, taking us to bigger and better things. So our thoughts are with his friends and family at this time. And that's where I would like to end. Thank you.